So first of all, I would like to thank the organizers for inviting me to this event, especially considering that I am neither a Dante scholar nor honestly a medievalist. And so at times I may look a little bit out of my depth. However, I have probably looked more than most into the medieval and Renaissance meteorological literature that deals with the problem of the place, nature, and evolution of the Earth, or lack thereof. So perhaps I can bring a small contribution to a better contextualization of Dante's most important meteorological writing, namely the Questio de Terra he famously discussed in 1320. As you certainly know, in this lecture, Dante addressed the problem of the relationship between the sphere of the Earth and that of water, as well as some of the natural causes that allow the emergence of dry land. In doing so, he especially criticized an apparently nonsensical doctrine that was very widespread in his time. This doctrine postulated that the surface of the ocean is actually higher than even the highest mountains, and that sources and rivers would actually flow upwards. According to most literature on the Questio, Dante finally brought some common sense into the field by delivering a deadly blow to that absurdly illogical theory. In this talk, I intend to reassess that doctrine within the context of medieval meteorology and show that actually it gave plausible answers to difficult physical problems that other models, including Dante's favorite, struggle to address. My argument is that this theory has always appeared nonsensical because its premises and its context has been fundamentally misunderstood by modern scholars. So let's start from the beginning. I will need to sketch a little bit what the problem was. So because of its vast implications, the relationship between the sphere of the Earth, intended as the element of Earth, and not the planet Earth, and that of water was indeed the fundamental problem of medieval and Renaissance meteorology, at least down to 1600. According to Aristotelian natural philosophy, the elements tend to settle around the center of the universe according to their specific weight or lightness. Earth would then occupy the lower place, surrounded by water, air, and fire. This simple model was complicated by the assumption that the elements continuously turn into each other. So water tends to turn into earth, earth turns into air and fire, and so on. So the stability of Aristotle's eternal universe implied that there must always be as much earth as water, air, and fire, more or less at least. And yet water is less dense than earth. So in order to contain the same quantity of the element, its sphere must be much larger. In a universe where the elements have reached their proper place, the Earth should be entirely immersed into a sphere of water, as we see here in this image. Obviously, this does not happen because we have very solid evidence that there is, in fact, dry land, since we are standing on it. Now, the why is straightforward. The theological reason is obvious. Dry land is necessary in order for terrestrial life, including humans, to exist. And for scholars such as William of Auvergne, Michael Scott, or Campanus of Novara, direct divine intervention was indeed a sufficient reason to explain the emergence of dry land. Still, most authors maintain that God acts in the universe through natural causes, that miracles should not be invoked if plausible natural causes can be found. So in the 12th and 13th century, a common answer was the diminution of the element of water that progressively turned into air and fire owing to the sun's heat. So in time, this led to the emergence of dry land. And in the end, it will cause the extinction of life on Earth when all water will disappear. So this model provided a naturalistic explanation for the separation of water and dry land described in Genesis, and for the great fire that would accompany the end of the world. In Dante's time, however, Aristotle's steady-state Earth had largely superseded previous directional models. So this explanation was no longer acceptable. The Earth has always been more or less as we see it, and always will be, since the beginning to the end of the world. As we know, Dante's and many others' preferred answer was that the Earth has a hump that emerged from the ocean, caused by direct divine intervention or an explanation favored by Dante, by the magnet-like attraction on the element of Earth exerted by the northern stars that were considered brighter and more powerful than the stars of the southern hemisphere. And I'm using the images that come from the 1508 edition of Dante's Questio. A common alternative to the hump theory held that some Earth is dry not because the northern stars raised part of it, but because the sphere of water and the sphere of Earth were not concentric. So the resulting offset between their centers caused part of the Earth to emerge. Which one of the two spheres had its center removed from the center of the Earth was the object of intense debate. Alexander of Aphrodisias had argued that being a fluid, water would always form a perfect sphere around the center of the universe. Aristotle's Earth, on the contrary, was a sponge-like body. We should not imagine it as a uniform body filled with earth. That was not the case. It was pervaded with veins of water, immense cavities, caverns through which winds and vapors can form, causing earthquakes, or can ignite, causing volcanic eruptions. Now, since the density of the sphere of the Earth was not uniform, one side of the Earth will be lighter than the other. So the center of the figure of the Earth, as in contemporary parlance, that is the geometrical center of the Earth, will not coincide with the center of its weight, which we would call the center of mass of the Earth. So as you can see on the figure on the left, if the geometrical center of the Earth does not coincide with the center of the universe, part of the Earth might emerge from water. Now, this doctrine was not only consistent with Aristotelian physics, but it also explained easily why only one big continent exists and why the antipodes were not inhabitable, according to most medieval mainstream, so as to speak, medieval cosmography. The ocean on the other side of the merged globe would just be too deep for dry land to exist there. Now, during the 13th century, however, a different variant of this model gained wide popularity. This variant postulated that the eccentric sphere was not the sphere of the Earth, but the sphere of water. As we've seen in the upper left image that was printed in the 1508 edition of the Questio, and with more clarity in the hand-colored English manuscript on the right that was written about 1520. In the second, in particular, we can see that there is a sphere of the Earth here that is at the center of the universe, as shown by the sphere of air and fire, and a sphere of water that is eccentric, so that some of the Earth can emerge, forming the famous inhabitable quarter of the world. And here we have the equivalent on the upper left corner in the 1508 edition of Dante's Questio. I have turned it 90 degrees so as to make it coincide with the with this image, with this manuscript. In the printed edition, actually the emerged Earth would be on the side, but it is perfectly equivalent. Restauro d'Arezzo, one of the supporters of this hypothesis, explained in his 1282 vernacular composition of the world that stars, just like magnets, could attract but even repel. And while the northern star attracted Earth, creating mountains, they also repelled water. And this effect was much more considerable because water is lighter, and being a fluid, it is easier to displace. As a consequence, the surface of the ocean was not only eccentric with respect to the center of the universe, but also higher, as in farther away from the center of the universe than dry land. Now, this solution retained many of the advantages of the other variant, such as the obvious inference that you cannot have dry land on the opposite side of our continent because the ocean is just too deep. And then it added another big advantage of its own. The advantage is that it explained why we can have water sources even on the higher mountains on the emerged hemisphere. Why was that a problem? This was a problem because of the common assumption that was not really dispelled until 1700, more or less, the early 1700s, that the cycle of water took place mainly in the underground rather than in the atmosphere. So water springs were supposed to be fed not only by the melting of glaciers and by rainwater, but first and foremost by seawater seeping through the subterranean channels that pervaded the body of the Earth. As you can see in this image from Athanasius Kircher's Mundus Subterraneus, it's a much later source, of course, but it still gives a clear image of how it was supposed to work. In the ocean here, we have whirlpools that suck in seawater, then seawater flows back to the Earth through these subterranean channels where it gets purified, it loses its salinity, and then it goes back onto high mountains where it feeds sources and the big reservoirs of water that, according to Kircher, existed under the mountains. The problem is, what is the source of the power that raises those subterranean waters against their nature on the top of mountains? In Kircher's time, a plausible engine was found. It was the existence of a central fire, as he famously depicted again in his Mundus Subterraneus, the subterranean world. Yet the idea of a perennial heat at the center of the Earth took hold only in the previous century, in the course of the 1500s, as Rink Vermi and Luca Ciancio have repeatedly pointed out. Before, the center of the Earth was normally the coldest place of the universe, being the farthest from the heat and light of the sun. And Dante probably agreed. As you know, the center of the Earth is incredibly cold, although in the comedy, the explanation for this cold is not properly naturalistic. But the basic implication was in good agreement with medieval meteorology. The center of the Earth is the coldest place. So you don't have this engine, the subterranean fire that can raise water to the heights of the mountains. Now, volcanic activity was explained not with the existence of a central fire, but with the ignition of vapors immediately under the surface. And usually it was considered to be too localized to provide a sufficient explanation to this problem, a sufficient cause to this problem. However, the pressure of a sphere of water whose surface is higher than dry land would readily provide this cause. Dante himself explains actually perfectly the argument of his opponents. If the Earth were not lower than water, the Earth would be completely without water, at least in the uncovered regions. And so there would be neither fountains, nor streams, nor lakes. And since the sea is the source of all waters, if the sea were not higher than the Earth, the water would not flow to Earth. For in every natural movement of water, the source must be higher. In other words, the pressure exerted by the sphere of water forced the subterranean stream upwards. After they reached the surface, water could then flow again according to its nature, that is, downward, until it reached the ocean. Rivers, of course, did not flow upward, according to this theory, nor did Dante ever claim so. The concept is so nonsensical that it actually applied every time we open a faucet. This is exactly the same principle that was, of course, known since the antiquity and to everyone who ever built an aqueduct. Now, in order to refute the eccentricity of the sphere of water, Dante has to come up with a different mechanism. And so he chose to deny the subterranean circulation of waters, claiming that water rises in the form of vapor and then turns back into a heavy liquid once it reaches higher and colder regions. which is the correct explanation, of course, as we know with a lot of hindsight. But while he tried to shore up this assertion with Aristotle's authority, especially Aristotle's meteorology, this was a rather isolated view, honestly. As far as I have been able to see, the belief in underground waters was rather universal. This is quite of an exception. And indeed, 2 centuries later, Leonardo da Vinci was rejected the eccentricity of the sphere of water, and also believed that the center of the Earth is cold, actually full of water. Made of the circulation of subterranean waters a cornerstone of his models of geological change. And yet, he was also unable to find the equivalent of the human heart. That is the mechanism that would pump those waters up to the surface. He was never able to find a solution to this problem. So now, while the eccentricity of the sphere of water was not without its problems, of course, perhaps we can now start to appreciate why it was so widespread and entertained in a number of popular works, especially vernacular works, including, for example, Brunetto Latini's Treasures, whose popularity is well known to everyone. Latini goes so far as to report the observation impossible to us that from the Atlantic coast of Africa, the ocean appeared much higher than the Earth. So if you go to the borders of the ocean, like here, you'll be able to see the ocean like hanging up over the level of the dry land. Yet it is self-contained, so that neither falls nor runs over the Earth. The anonymous commentator of a 14th century Florentine meteorology that was studied by Rita Librandi reported the same fact, allegedly learned from trustworthy merchants of Genoa. Why a merchant of Florence should consider merchants of Genoa trustworthy is another fascinating problem, but at least they were not from Pisa. Anyway, he added that there was no need to travel to become convinced of the physical reality of this phenomenon. All you had to do is to take a circular vase, fill it completely with water, and you will see that its level is higher in the middle than along the rims. Dante himself went to some length to refute yet another observation, namely that sailors often have to climb on the mast to see mountains that are invisible from the deck, as if those mountains were actually below them. Indeed, many authors argue that water must be higher than Earth because this is what senses and experience tell us. Now, the idea that the water can go upwards and that the surface of the ocean was higher than the mountains remained, of course, highly counterintuitive. But I would argue that, unlike what perhaps a bit superficially stated in much scholarship, this doctrine reveals not faulty reasoning and lack of common sense, but on the contrary, intellectual sophistication. Medieval authors and their readers, that were in many cases vernacular readers, were willing to accept the physical hypothesis that best explained the observed phenomena, like the existence of sources on dry land, even when they seem to defy the immediate response of the senses. And after all, do we all agree in this virtual room that the place where we are sitting spins around the center of the Earth every 24 hours while traveling around the sun at 20 miles per second? No objections? Probably not. Why? This sounds extremely counterintuitive. Yet you accept the conclusions of modern astronomy because they best explain the observed phenomena, even if they seem to contradict our immediate perception. And so the doctrine of the eccentricity of the sphere of water was no different. Many authoritative authors and their readers accepted it because it seemed to best explain a vast range of phenomena, particularly the existence of water sources on mountains. Several centuries ago, the motion of the Earth appeared every bit as nonsensical as was Einstein's relativity, to cite another example, no more than 100 years ago. And now I can actually thank you for your attention, and I am eager for your feedback.